Hey guys, it's Mr. DeFelice. Today we're going to finish up the properties of exponents and look at one of the last properties you can use to simplify when you have exponents. So we're going to complete the table using the idea of repeated multiplication. Then in the final row we're going to use the pattern to write the exponent rule in general. The first one they did for us, and then we're going to keep working through the other ones together. So it says these problems are also use the fact that common factors on top and bottom of a fraction can be canceled. For instance, if you have 3 times 4 on top of a fraction, divided by 4 equals 3, since the 4's on top and bottom can be thought of as 4 divided by 4, which is just 1. So what's happening here in this problem, they're just canceling out the 4's, and then you get your final answer of 3. Because if you have the same number on top that you do on bottom, you can cancel them out, because when you divide them, they equal 1. So they do this property in this problem here. 3 to the 5th, they expand 3 to the 5th, over 3 to the 3rd, and then cancel the ones that match on top and bottom. And then the final result is that you have 3 squared left on top. So let's see if we can figure out the pattern as we work through these. The next one is 6 to the 6th, so I'm going to expand 5 6's over 3 6's. And then cancel out, so I'm left with 6 to the 3rd. 5 squared on top, so 5 times 5 over 5. So my final answer is this 5 to the 1st. 10 eighths on the top. Over 5 eighths. I'm going to cancel top and bottom, so I'm matching top with bottom. And I'm left with 8 to the 5th. Anybody figured out the pattern yet? In this one, if you take a look at your exponents, when you're dividing with powers and that have the same base, so 6 is your base here, I can take a look at my exponents, and it looks like all I'm doing is subtracting them. 6 minus 3 is 3, 2 minus 1 is 1, 10 minus 5 is 5. So when you are dividing, all you do is you take your exponents and subtract them. So let's take a look. Does this rule work for 4 squared over 4 squared? Explain. If so, what do you get at the end result? So our rule said to subtract the exponents if they have the same base and you're dividing them. So this turns into 4 squared, 4 to the 2nd minus 2. So it's 2 minus 2, which equals 4 to the 0. If you type that in on your calculator, you're going to get 1. So this is an interesting result. We're going to have to come up on the next sheet and look and see why this turns out to be 1. Check it out for this one. If I do 0 and then 4 minus 2, that's 0 squared, and 0 to any power is 0. So it does look like it works for this number. But let's take a look at why this comes out as a result. Okay, another rule you'll see deals with fractions. When you have an exponent, you're going to see a property with the fractions as well. So the same idea, we're going to complete the table using the idea of repeated multiplication, and then we're going to look for a pattern. These problems use multiplication of fractions. Recall, when you multiply two fractions, you multiply the tops and the bottoms separately. For instance, 3 over 4 times 5 over 2 is 15 over 8, because 3 times 5 is 15, and 4 times 2 is 8. So you multiply the bottoms together, and you multiply the tops together. So when you have an exponent, you're just writing it however many times you see it. So it says 3 over 2 to the 3rd power. And then, remember, you're writing what's on top, you're multiplying together, and what's on bottom, you're multiplying together. So 3 times 3 times 3 is on the top, and 2 times 2 times 2 is on the bottom. So your end result is 3 to the 3rd over 2 to the 3rd. Same idea with this guy. 4 5s, and 4 6s. So at the end result, you get 5 to the 4th over 6 to the 4th. Because I wrote 5 6ths 4 times. Here I'm writing 1/2 2 times, 1 times 1 is 1 squared. 2 times 2 is 2 squared. I'm not going to simplify these any further because I'm looking for the pattern at this moment. Next one is 2/9 to the 5th power. So I'm going to write 2/9 5 times. So on top I've got 2 to the 5th, and on the bottom I've got 9 to the 5th. So this one's exponent rule I think is pretty self-explanatory. If you have a fraction inside of parentheses, you can basically it's like distributing the exponent, the numerator and the denominator. So in this problem it becomes x to the n over y to the n. Whatever the exponent is on the outside of the parentheses, they both get it on the bottom. So does this rule work for this number? Explain. If so, what do you get as the end result? Well, the rule works, but the issue is you can't have a denominator of 0. So this number does not exist. I could use the rule. It'd be 5 over 0 times 5 over 0 times 5 over 0. You'd get 5 to the 3rd over 0 to the 3rd. But again, you can't do it because you can't have 0 in your denominator. Okay, last one. This is going to explain why something to the 0 power really turns out to be 1. So same idea. We'll expand and then we'll come up with a pattern. So these problems use the exponent rule for number 4, which is the page we started off with in this note video, to complete the second column. To complete the third column, remember what you get when you divide a number by itself. Alright, so let's use the exponent rule for number 4. So if I had a number raised to a power over the same number raised to a power, I could subtract and then get my exponents. But here's what's happening. Let me show you why this works. If I expand 2 to the 3rd 3 times over 2 to the 3rd, I'm going to cancel every 2 out, right? And nothing is left over. But remember, when you cancel for division, you're not getting rid of it. It's turning into 1, because 2 divided by 2 is 1. So this just turns into 1. And you can see that it's something over itself. When you divide something by itself, it's 1. So same thing here. 5 to the 4th minus 4 is 5 to the 0, which is 1. You could, if you wanted to, simplify this and use the powers, if that helps you see it. 9 squared is 81. 81 over 81 is 1. Using the exponent rule, you get 9 to the 0, which we've identified as equal to 1. Same thing over here. Let me use the exponent rule this time. So x to the 0, or x is just like a number above, x to the 0 is always going to give you 1. No matter what the exponent is, or excuse me, the base is, it's always going to be 1 if it's raised to the 0 power. Does this work for 0 to the 0? Well, that one's a little tricky. Remember, 0 to the 0 would be 0 divided by 0, and you cannot do that. So no, it does not work for 0. Okay, try the practice problems, and then that's it for today.